In this class, we are covering P5, question 2, part A only. They will give you an equation and they will ask you about gradient and y-intercept. The easiest question could be, they'll say that P is the pressure, T is the temperature. In a certain situation, in a certain situation, in a certain situation, pressure P of a gas is related to its temperature as P is equal to K times T cube plus T. K and D, this is the easiest question that they can give. K and D are constants. A graph a graph of P is plotted against T cube. What will be the gradient and y-intercept? Gradient is K and y-intercept. One second, but how we are finding that? So this is the question basically. Now what you are going to do, you will compare the given equation with y is equal to mx plus c. Compare the given equation with y is equal to mx plus c. For example, our given equation was is P is equal to K times T cube. P is equal to K times T cube plus D. So as a result, if we compare it to the standard straight line equation, that is y is equal to mx plus c, then you see pressure, if it's on y-axis, and t cube, if it's on x-axis, then gradient is k, and y-intercept is capital D. So k is the gradient and capital D is the y-intercept. So this was the method. Another example for part A is, second example, what if you are given an equation in which the power is unknown? For example, if you're given with P is equal to K times T power N, here K and N are constants. And now in this question, first thing is, if they ask you, generally they don't ask, but what if they ask you, suggest access for a straight line graph. This is the first thing. Now, the answer to this part is, whenever you have variable in the power, you have to take log or natural log. So you must know that this is a rule. Whenever power is not a number, but a variable, then either take log or natural log. When the power is not a number but a variable, then either you will take log or you will take a natural log. E is equal to K T power N if we take log on the two sides. Log of P is equal to log of K T power N. So this will become log of P is equal to log of K plus log of T power N. This will give us log of P is equal to log of K plus N. In log, power becomes coefficient, N log of T. So after taking this log thing, you see this equation becomes a linear equation, an equation which can give a straight line graph. With this equation, you cannot get straight line graph, but with this equation, with log form, you can get a straight line equation. However, if you have no idea about the rules for log, then there is a problem and you need to understand those. For example, if we write, now we have log of P is equal to N log of T plus log of K. If we compare this equation with y is equal to mx plus c. Then here you see gradient will be n, and y-intercept will be log of k. Gradient will be n and y-intercept will be log of k. But the problem here is if you have no idea about the rules for log, then you'll get trouble. So you need to know rules for log and natural log. Log and natural log. Initially, we'll cover log and then we will also cover natural log. So rules for log. Log works in this way. For example, if you have 10 power 3 and you know it is equal to 1000, then log of 1000 will be 3. Basically, when we say log of 1000, it means that how you will perceive it or read it. If it is log of 1000, then basically the examiner is asking you what power of 10 makes 1000. It goes in this way. For example, if it is written that find log of 35, what this means? What power of 10 makes 35? However, if we write log in the simplified form, if you say log of 35 will return an answer x, then obviously it means that 10 power x will give an answer of 35. So this is the main concept. The concept here is when you take log of some number, it basically represents what power of 10 makes that number. So this is the concept here. And furthermore, what is natural log? Let's understand that. For natural log, it is specifically e power. So if we take natural log of, for example, 20, it means that what power of e, what is e? E is a button on calculator for physics students. For math students, it could be something more than that, but for physics students who are not taking mathematics and they are just taking bio, for them, E is just a button on calculator. If you press, if you look at calculator, you have a button of log here, and above that you have 10 power. With that, you have a button of natural log on your calculator, and on that you have e power. So log goes with 10. In the same manner, natural log goes with e power. So e is something, what it is, it's not your concern. So it is related to log basically. What power of e? If you press e power 1, you'll get an answer of 2.718, I believe. So e is just a number with a specific value. What is its purpose? For physics course, it's not needed. So what power of e makes 20? So we'll translate it like this. For example, if you write natural log of 20 gives an answer of x, it means that e power x returns 20. e power x returns 20. So this is the concept here. So basically natural log states that if you take natural log of a number, it states that what power of e will return that number. For example, if you have natural log of 235 and it is equal to x, it means that 235 will be equal to e raised power x. This is the concept for natural log here. Then other rules for log and natural log. The second rule is product becomes sum. What is the importance of this rule? When you have product, it is non-linear. When you go with sum, it becomes linear. So in log, product becomes sum. For example, if you have log of a into b, it can be written as log of a plus log of b. However, you cannot open log of a plus b. This rule will not apply here. And if you have log of a into log of b, then this rule will not apply here as well. This rule is for log of a into b when a and b are multiplied. So the rule is not for these two. So whenever you have log of a into b, it will become log of a plus log of b. For example, in the same manner, if you have log of a over b, it will become log of a, it will become log of a minus log of b. So log of a over b, it is the second rule, a third rule, I should write that. So if it's product, it will become sum. Third rule, division or quotient becomes difference. So when you take log, the division becomes the difference. How it works? For example, if you have log of a over b, it will become log of a minus log of b. So in case of log, division becomes difference. So this is the second rule for log, third rule in fact. Fourth rule for log is power becomes coefficient. This rule is basically if you have log of p power n, then it will become n log of p. The power in log becomes the coefficient. So if you have log of p power n, then it will become n log of p. This is rule number 4. And the fifth rule is if you take log of 10 itself, it will be 1. And if you take log of e, sorry, natural log of e, it is also 1. So these are some rules for log that you should know. You know some examples related to that. Example number 1 about question number 2, part A, paper 5. Examiner says R is equal to e power minus k times t. R is resistance of a semiconductor. R is resistance of a semiconductor at temperature. R is resistance of a semiconductor at a temperature T. R naught and K are constants. R naught and K are constants. Now the question is, what should be what should be the axis? What should be axis of straight line graph? What will be the gradient? And y-intercept. What should be the axis for straight line graph? And what will be the gradient and y-intercept? The first step is, since it is e power, you have to take natural log. So it would be r is equal to r naught e power minus kt. Here we should take natural log on the both sides. It will become natural log of r is equal to natural log of r naught e power minus kt. Now, when we solve it, it will become natural log of r is equal to natural log of r naught plus, if it's log, then the product will become sum. And whenever you have e power and variables are in the e power, then you have to take natural log. Natural log of r naught plus natural log of e power minus kt. So finally, it will become natural log of r is equal to natural log of e power minus kt plus natural log of r naught. We have written the independent variable in the first term. And then the power should become the coefficient. This power will become the coefficient. It will become natural log of r is equal to minus kt natural log of e plus natural log of r naught. As a result, finally this will become, natural log of e is 1. So it will become natural log of r is equal to minus kt is equal to minus kt into natural log of e is 1 plus it is natural log of r naught. Now, if we compare it with the standard equation of straight line, it would be, this is y, this is mx plus c. So here we get this thing. So natural log of r is equal to minus kt. Basically, we got this. Natural log of r is equal to minus kt and plus natural log of r naught, which leads towards y is equal to mx plus c. Here we have the axis should be y-axis must be natural log of r. X-axis must be simply t. Gradient will be negative k. And y-intercept will be natural log of r naught. So all of this. However, if you have a relation in which the variable is in power, for example, we get this example in which p is equal to k times for example, we have k times t power n. Here p is pressure, t is temperature. Now same task is there, k and n are constants, but we have no idea what is the value of n. So when we have a variable in the power and we need a straight line graph, we have to take log again. So if we take log of this, then what we will get is, if we get log of p is equal to log of kt power n, it will lead towards log of p is equal to log of p is equal to log of k plus product becomes sum plus log of t power n. Now this n will become the coefficient. So finally it will become log of p is equal to log of k plus n log of t. So if we compare it to y is equal to mx plus c, if we compare it with y is equal to mx plus c, so what we'll get? Basically, y is equal to mx plus c. It would be log of p on the y-axis, log of t, because p and t are the variables on the x-axis, n will become gradient, and log of k will become y-intercept. So here we get this quantity on the y-axis, this quantity on the x-axis, and our gradient would be n, and our y-intercept would be log of k. This is your part A of question number 2. So we'll cover every part in one slide each, and there would be 6 slides in total. We are done with 2 slides. First slide was about introduction. Second slide is about part A. Then we have 4 remaining slides. So students, this was introduction of part A of paper 5 question number 2. Take care students. In the next slide, we'll cover part B.